Another example, we have it here, is this one. They try here to showing you the running for a container. Everything is similar to what we talk about. This is the name of the image, HTTPD. It looks like a web server, and it is 2.4, not latest. I'm mentioning the version. Maybe 2.4 is the latest, but you are mentioning here, you are more specific, and you are mentioning the port number. And notice that you have here, you are using the -p flag for port number. You are binding the host, the container port number with the host port number. Here, always remember that we are starting with the host port, then the container port. So I have a container. This container is called web container. And it has inside, and it is going to be created based in HTTPD image. And it will have a port number here, 80. And this port number is tied or bind with my host machine port number 8080. So anyone from outside this host would like to access this container, the content of this container, he will go to 8080 in the host, and the host will send it to 80 in this one. This is with the help of this publishing flag, by the way, publish flag. Everything else, we talk about it. We talk about all these things. Okay. Now, Docker images. We talk about Docker images. We understand that we are creating container from it. But I said before that you can create your own image. In our examples here, whatever with Hello World or Ubuntu, I was dealing with images that already created. Let me give you another example for images that already created for you. We saw Hello World, we saw Ubuntu. I would like to show you another one. And I would like also to show you something. Let me share with you this website. If you'd like to practice with Docker, we have this free website. You need to have an account with Docker, that's it. So I would say login with Docker. And it should login successfully. Just hoping. Don't forget my credential, because I already forget it. And it will give you access to, yeah, I hope he saved it. Good. Now, if I click start, it will give me capability to run with the machine with Docker installed on it, and I can do whatever I want. All these commands that I did it in Linux machine, I can do it with this one. Let me close this, guys. Free some resources, machine. So I'll say add a new instance. And as you can see, same command that we was working for with it. It's like Docker info, for example, it will give you the same stuff. Docker version. But I don't think that it will accept from me the copy and paste. So let me create one Docker here. I will say Docker run or container run. It's up to you, but till the end of the year. Docker run, unless they change their mind and keep both. Docker run -d minus name hyphen name, and I will call my container web, and -b 80 480. So I'm making the host machine and my container machine using port 80 here, port 80 there. But you can change it for sure. Best practice to change it. Oops. And here I'm trying to use one you know, one image that already created with a website inside it. Just need to make sure that I'm timing it correctly. No spelling mistakes. Let's see. It's from lower side. Okay. Get the A here. Okay. And very long name for. Long name for. Just I need to make sure. Yeah. Missing. Missing. Yeah. Guess I forget the L here. Again, he's telling me that this image does not exist because the name itself for sure is right. B-L-U-R-A L-S-I-H-T. Maybe I have T-I-O-N here. Yeah. Huh? Responsible denied. Something wrong. Again, doesn't. Let me check the name for it. I guess I have it in my files. So, yeah, this is the right name. Unless they change the name of it. This is the right N-I-N-I-G-E. N-I-G-E. L-B-O. Okay, there's no I. Right. Should be running fine. Just let me remove the I that I added. Because this will fix it. Still, Reboot not exist. Anyway, I was going to have it and show it to you here. Anyway, you still can do whatever you want here and Docker run hello world should be working fine with you and start downloading it, showing you everything. I was trying to show you example from specific image. It looks like it's not there. Anyway, so now, as I said, we need to talk about images, and I said that you can create your own image. To create your own image, you need to create a file called Dockerfile. And inside this Dockerfile, there is some commands you will write it. It is creating layers. So I have here with each line a different layer. And these information that we are seeing here is the content of a Docker file. And the execution of the Docker file will start from the beginning to the end. And normally we will start with from, where we need to mention like a parent image that we will make our images based on it. This is very important. When you create image using Dockerfile, remember in the end that inside the Docker file, you will mention a small image. We call it parent image that's going to be used to create your image here. Now, you will tell me, okay, what is the difference? So I will let me create let me use an image already exists. No, because here, for example, the parent image could be Python version 3. Then later you will mention a few things that you would like to see it exist in your image, like running this script, do that, don't do this. Then later when you create the container, I'm following these instruction and I'm using this parent image. But for me, the image is the one that I'm using here. But inside it, I have these things. Now, let me show to you an example. Let's return back to our Linux machine, and I promise that we are going to take our lunch break soon. Just one slide that we need to finish. After this talk about Dockerfile, then I will give you time. So let's go to my machine here. I would like to create one folder. This is my working directory. My working directory, let's call it. My desktop. Inside it, I would like to have two files, these two files. So let's take them. This is the Python file for timing, and I have the Docker file. Now, I have a Python file, and I have a Docker file that I would like to use it to create an image. First, let's try to see the Docker file. What is inside? By the way, we are using Visual Studio Code here. Remember that. I have 6 layers, or 7 lines, or 6 lines. The first line saying from Python 3. That's mean this is my parent image. I will go and once I create an image from this file, that's mean the Python 3 will be inside it and it will be installed once we create a container. Then maintainer, sorry, maintainer. Maintainer is my name, label, just the metadata. So the first two line, the second and third line here is just metadata. Then I'm adding from my host machine, which is here, this directory, my working directory, I'm adding a file called time.py, and I'm putting it in the root of my container. You can use add, you can use copy. I will go for these commands in a minute. Then my entry point is, what is your entry point? It is like the default command that should be run in the beginning. It is Python 3. Then in the CMD, I can type time.py, which means run Python and run this script for me. Now, if I open my file here, time, you remember we just show it in the beginning of the day. We saw it in the beginning of the day, and it is giving you the date for and timing, right? Nothing much. I would like to have the same output, but as a container. Now, what I will do here is I will go to my desktop. Just let me take the command that I'm going to type. Here it is. Now, let me save you. Edit, just to make things clear for you here. Okay, now I will say cd my working directory. Now sudo docker build, and the name is, or the tag, I need to add tag to name my container, my image here, my image. So I am creating an image called my image. I'm using docker build. The dot here is very important after the space. It means take anything you can find inside the working directory, take it and create the image from it. And I don't need to type Dockerfile. Why? Because he will check my working directory, which is my WD, and he will try to find if you have a file called Dockerfile. Remember, Dockerfile is case sensitive. The D should be capital and everything else should be small letter. This is a case sensitive and the standard name. And by the way, if you change the name to something else, you need to mention in this command with -f, you need to tell him that the file name that we are using is called something else. Yes, it is a Docker file, but I'm not calling it with the standard name Docker file. Anyway, now if I press enter, password for the root, step 1, he's getting for me Python 3. Step 3, pulling for, and he's getting it from Python library. He's now downloading Python 3 to be added inside the image. Huh? And it will take time. Then once he finishes, he will start doing the step 2, which is the second line in the Docker file. Okay, it's continue. We completed seconds. Extracting. It's taking a little bit time. They don't want to jump to explain these lines or these commands from add before we finish. Yeah, you see, step 2, step 3, step 4, step 5. By the way, he's creating a hashing as a fingerprint for each step also. Now, sudo docker images. I have a lot of images in my machine here, but here it is, my image. Just created 19 seconds ago. Now let's create a container from this image. So what I will do, I will say this command. Let's take this command. Now I'm telling him run, Docker run, or Docker container run. Both are the same. Hyphen name. I would like to create a container called my date. And the image that I'm going to use is called my image. And guess what? He just ran the Python script for me. The container is running for me. I have a container called now my date based in the image that I just created. Sudo docker bs, nothing running. Just, yeah, here it is. Here is my container. And what is the command that it is running once this container is running? It is python 3 time.py. It is running this script that I have it, and that I added in my image by saying add time.py. Okay, so
in-house friend. May pera ka, di pala kikitin ko yun.
So you just now understand what is Dockerfile? I guess it is time quickly to try to understand By the way, if you type Docker history and the name of the image, it can tell you exactly how for the last how many days it is created, each step from the steps that create the image itself, and each step will have its own SHA number. Layers information in Linux machine will be saved in this path, by the way. Now, let me show you what is the content of the Docker file that we used or we can use it. By the way, your working directory is called build context. Remember that as a terminology. The my WD that I was using in Linux machine right now, this directory is called build context. Since it has Docker file inside it, it's called build context. Now, from, it is the first line that you should have inside your Docker file, and normally it will specify the parent image that your image will be based on it, like Python, Linux, whatever. Copy is going to be used to copy files or directories from the build context, which is the host working directory, to the container. Copy can be used or add. In our example, I used add. I didn't use copy. Both of them are giving you here the same result. But if what is the difference? The main difference between copy and add. If you have a compressed file like .tar in your working directory, and you would like to take it and copy it in a container inside the container and extract it, in this case, add is your choice, not copy. This is the difference between both. Environmental variable, to mention what is the name of the environment, to mention password, username, any secrets. env can be used here. You can use it with equal sign or without it. You can create a working directory inside your container by using work dir. Label is just a metadata name about someone who create or the company that create this container. If you would like to run a multiple command in the shell in the container, you can use run. Maybe you would like to install some applications or tools. In another meaning, you might have a container based on Ubuntu as a parent image, and you have some files will be running here, but these files will need another application to be installed inside the container. In this case, I can use abt, which is a tool that we use it to install software and packages inside our Linux machine, especially if it is Debian based, not Red Hat. In this case, I can type abt update, abt install, and each one of them I can have it in run command. Now, or run layer, or run line. Now, remember something, it is recommended and sometimes why we will need run to run some commands. Sometimes you will have a file, but this file we need to fix the permission for it using shmod Linux. So I need to do that before I start using this file inside my container. So run is good. It can run commands inside your container. Sometimes you will say, okay, what if I have like 3 or 4 commands that I would like to run? Should I type 4 run commands or 4 run? No, this is not the best practice. Docker community doesn't recommend that. It's recommended to type 1 run command, then type the one run, then type what you would like to install, abt install, for example, something like git. Then you have another command, have a space, then put backslash, then space, then you can in a new line you can enter the new command that you can run. So in this case, Docker will understand that when I'm creating a container based on this image, when it comes to this line, I'm not executing with run one command only, but I have few other commands also, and separated with the backslash, instead of having it with 4 run command. volume. Now, containers will need to access, sometimes will need to access your hard disk to save some information. It will have some persistent data that cannot be lost. We cannot lose these data. Now you will tell me why I will use the data. If the container exists, everything will be fine. Yes, but what if you stop the container? What if you delete the container? You will lose these data. And even if you stop the container. So it is always better to save the container information. Maybe the container will have some login capability, will have the capability to create username and password, and he need a database to save it. So for sure he will need access to your hard disk. These are persistent data, and we can have it with volume keyword. Expose, this is just opening a port. If you would like your container to have a port open, you can use expose for it. CMD to execute some command, but this command is different than run, because now you will tell me, wait a minute, we was talking about run, and now you are talking about CMD, and both of them can be used to run commands. Yes, the main difference that you need to put it in your mind that unlike run, the CMD command does not execute while building the image. It will be executed when a new container started from the image. So in another meaning, when I have in run apt install git, that's mean when we create the image, one of the steps when we are creating the image is having git installed in it. If I said apt install git with cmd, that's mean I will not run or install the git now. But when you create a container from this image, when in the creation of the container, I will start installing the git. I show you one Docker file that I have it. Here is another one. This one is good because again it is showing you another difference between entry point and CMD. Here I'm installing a parent image called Albine 3. Entry point, what is the command that by default will be run once we create a container from this image? It is ping. And what is our CMD? I'm saying I need to send 3 packets to 48 48 DNS, Google DNS server. This Docker file, I can make it to create an image. I will call it Binger. Now I can create a container based in Binger. By the way, you will tell me, why? Hey, wait a minute. What is minus minus RM? I saw it in Git. It was for removing, right? When we remove something, and we saw it with Docker here. RM for removing a container and RMI for removing an image. Why we have this command here when we are creating container? When you do this, you are simply telling Docker, create a container. This container will be based in this image, okay? And run the container. Once you finish, delete the container. I only need the container to be run once, show me the result, and delete the container. So I'm adding hyphen hyphen rm. And if you type docker bs minus a, you will not see this container actually, because it is created, run, and deleted all in one line. And as you can see, he is giving you the action. Anyway, was the example for this part. Now, just quickly, I know that it's time for lunch break, but I'm trying to finish this part so you can, you will be able to, yeah, you will be able to go for for labs after lunch break. Then we will return back to continue with, again, we still with Docker. We need to continue with Docker networking and Docker compose. Then we will go for, again, labs, then GitLab, and we have a long day. Now, quickly, golden images. What is golden images in Docker? Simply, it is similar to virtual machine when you have, or when you have a ISO file, that it is a good version that you can use it. Normally, when you say I have a golden image, that's mean this image is secure, and if it is using some parent images, for sure it is using parent images inside it. By the way, you can create a container image from scratch, not only a parent image, but it is another story. Anyway, that's mean that the parent image is secure. No, if there is any security patches, it will be installed. It's already installed. It is approved, and this is a stable version from our image here. That's mean I'm confident that any container I will try to create it from this image will be running fine, will be secure and stable. This is what we call a golden image. It is always good to have image tag, and image tagging is important, like latest, like what is the version. As I said, we can use latest or version. The problem with latest, I will mention it in a minute, but one of the important thing that we need to talk about it in golden images, that it should be always coming from trusted registry. Trusted registry means simply Docker Hub or on-premise GitLab or the cloud GitLab, but from your own account. In another meaning, it should be always coming from trusted resources and stored in the trusted resources. This is very important for sure. Should be tested, approved. As I said, if you'd like to pull or push any image, you can do that, but you need to type Docker login, then the name of the server that we are dealing with, the trusted source. If it is a GitLab, type the IP address or the fully qualified domain name, type your username and password. Then you can push or pull using Docker push or Docker pull to your container. The most important thing is the URL that we are using. Normally it will be registry.git.lab. This is with GitLab. Then the name of the group in the GitLab. You remember when we talk about GitLab, we said the group will be affecting your URL here. Then the name of the image that we have it inside the container, which is Python 3, Python 3.7 latest. The word latest is a little bit tricky. You need to remember that even when you push a version, like here, you are pushing Python 3.7 latest, or the version is latest. Latest is just a name you are giving. If you have an image and you call it image DevOps latest, then later you create a new image. What you will create it. If you push it, it will not change by itself. Latest is not dynamic. So you need to remove this version that you mentioned it latest and put another one with the term or the tag latest. Also, one of the important things that we need to remember is safe processing practice. For some reason, just hope that, yeah. Safe processing practice. What is safe processing practice? If there is some secrets, um, username or password, a database credential to access a database, any information like this, it is not good to have it in your Docker file. Your Docker file can have some important information, including some information that you can put it using the env, the environmental variable, and you can include some secrets. It is better to not have it hard coded inside the Docker file. It is better to have it in a separate file, and from the Docker file, you should call it, or from the command line that you are creating, sorry, the image, you should call this file. But you can mention in the Docker file that you are going to use the information in this file for that. The option that you can use with Docker run will be hyphen hyphen env file. This is the option that you can add to Docker run when you create. Uh, just let me. This is the option that you are going to use when you use Docker run. And another meaning, let's take this example. Docker run hyphen hyphen env file, and there is a file called env file db. I would like to create a container called netnvdb, and I'm using this image on it. But remember to take any environmental you will need, like username and password, from this file. Check it, and you will find the information on it. Finally, I talk about persistent data and why we need it with the container. There's two type of persistent data you can have: volumes and bind mounts, and you need to remember the difference between them. They didn't explain it that well in the material, and in the lab they will mention bind mount, but again they didn't explain it that much, even if you are going to use it in the lab. Volumes is simply telling my container we will use this directory with this path as your hard disk, as your similar to VM versus VHD file or BMDK file. Normally, I will save the volumes in this location. In the host machine, non-Docker process will not be able to change the data. Very good. This is secure. And there is something very important. If you would like to create your own image and you would like to create containers from these images that can have a persistent data in the hard disk, in this case, volume is the only option that you can have. Volumes is um, typically included in your Docker file, and it is the only way to create in Dockerfile something like that. This is happening only with volume, not with the other one, bind mounts. What else? Docker volume ls will show you all the volume in a host. Creating a volume, you can type Docker volume create. Inspect, you can type Docker volume inspect to get some extra information about that. Now, what the other side? So in general, in real life, you will work with volumes more. Here, for example, you can see, you can type Docker volume ls. You see that you have a volume here. Now, Docker volume inspect, and type the hashtag for it, and sorry, the hash algorithm for it, the fingerprint, and you will find that it is telling you information about it, including it is showing you in the host file system where is this mounted. In the host file system in var lib docker volumes, you will find folder with the name fingerprint tag for our volume. And later you can mention this volume name in your Docker file. So you are telling him go and use this one. Now, what about bind mount? And what is the difference between this one and the other one? First, non-Docker process can modify the data on that path anytime. So I have a container, and he will use this directory, my hard disk. Okay. But anyone else can change the content of this directory. This will affect what? Think about it. What if I can take a malware, put it in this directory, And the container, once it is run or started, it will deal with this directory like it is on hard disk where he can save his persistent data. And maybe this malware will do something bad for the container. Could happen. So that's why we don't like bind mount that much. Anyway, bind mount cannot be used in Dockerfile, like volume. No, cannot use it. Also, we have something. When you create a bind mount for your container, you can use -v or volume or -- mount. These two flags can be used when you create a bind mount. The problem when you are doing your lab, they will use these two and you will not understand what he's doing. You will see that both of them almost the same. Yes, I'm mounting the same directory with -v or with -- mount, but what is the difference? The difference is very simple. With -- mount, the folder that you are mounting should be exist. In another meaning, you are saying that I have my folder 1, and this is a folder. If you are using -- mount and this folder is not really exist, you didn't create it before, Docker will give you an error. With -v or volume, he will create this directory even if it does not exist. Finally, something beyond our talk or our official material. You remember when I said that this is the last thing before you taking your lunch break. You remember when I said when I was using my Docker, don't have it here anyway. You remember when I was creating an image? Yeah, I have it here. I already created the image here from Dockerfile, from this Dockerfile. If you remember, when I create the image, I said the dot here is very important. Space dot, it means take anything in this directory. Now, in real life, in production environment, you will see that your directory has a lot of things, and these things not necessary to be a part of my image that I would like to create from this Docker file. So what to do? You can create something similar to Git. We have the same concept in Git, by the way. We have it in Git. We call it .git ignore file. We have .docker ignore file. In .docker ignore file, I will mention few file names or some group of names. And if you saw it, if when I'm creating an image, if using Docker, if you are seeing it, don't take it or use it as a part of our image. Like any folder or file with .git. Any file starting with Dockerfile, but with something else. I'm adding starting. README for Visual Studio Code. Docker Compose and anything after that, like Docker Compose 1 to 3 or 2020. Don't take these files and add it to my image. So when you want to avoid copying unnecessary file or folders into your image, you can use or create a .docker ignore file. It is similar when we like to add some files in Git, in Git, then commit it. I said you can type git add. You remember I said you can type git add dot, right? And I said he will take everything in the folder and put it in the staging data store. In this case, when I'm doing this, he will check the .ignore file. Also, we have the same concept with our Git here. Okay. Any questions? Everything is fine? Tell me before we start talking about the labs.
All good.